When we look at these big mass extinctions of the past, in 4 of these events, some of the first animals you see in the succeeding geological period are cephalopods. They arise quickly. They're like weeds. They take over very fast, and they start getting as much of the resources as they can get. The cephalopods always, by the first turn of the course, they're always in first place.
Hello and welcome to Cat Among the Penguins. I'm Jenny Hickman.
And I'm Rebecca Nesbitt. Today we're asking the rather unusual question of, are we living through an octopocalypse? Over the past year or so, the UK has seen an unprecedented rise in the numbers of common octopus. Octopus are incredible animals, and rising populations is often a cause for excitement, especially among divers, for example, who get to see them. However, other evidence suggests that rising populations of octopus and other cephalopods could indicate something more concerning. It could be evidence that the Earth is undergoing a mass extinction event.
In the past 500 million years, it's thought that Earth might have undergone 5 mass extinction events. The most recent of these was the Cretaceous mass extinction, 66 million years ago, in which the non-avian dinosaurs were lost. While much mystery still surrounds the extinction events, we know that many were likely caused by catastrophic events such as volcanic eruptions and asteroids, and profound climatic changes, such as changes to the Earth's temperature and impacts such as depleted oxygen levels in the ocean. We can also get insight from the fossil records showing us what species might have suffered and what species may have thrived in these changing environments.
Many scientists have been warning that our planet could be undergoing its 6th mass extinction event. As far as we know, Earth's normal extinction rate is somewhere between 0.1 and 1 species per 10,000 species every 100 years. A mass extinction event, on the other hand, is when species vanish much faster than they're being replaced. This is usually defined as about 75% of the world's species being lost in a short period of geological time, less than about 2.8 million years. The current rate of extinction is thought to be around 100 to 1,000 times higher than the pre-human rate of extinction.
The Global Assessment Report on Biodiversity and Ecosystem Services estimates around 1 million animals and plants are now threatened with extinction, more than ever before in human history.
It seems as though the ecological signs may also be starting to become more obvious. In this episode, we find out exactly why a rise in cephalopod populations could provide even more evidence of what we're witnessing here.
Yeah, so let's start by talking a little bit about what does an octopus bloom actually look like. So the first reports of this came in from fishermen who were pulling up crab and lobster pots and finding them not filled with crabs and lobsters, as you would expect, but with very satiated octopus for whom crab and lobsters are a favourite meal. An amazing thing about octopus is that they are almost entirely soft and can squeeze through tiny holes into lobster pots. They then use a parrot-like beak to make a little hole in the shell of hard animals like crustaceans, and they inject venom into them that dissolves the tissue, and then they suck it up like a little crabby soup.
Around the coast of Devon and Cornwall, common octopus catches in 2025 were around 65 times higher than annual catches from 2017 to 2024. In some ways, that's good. That's a new octopus fishery. But it's not all good news because, as Jenny said, octopus love crabby soup. And the result was that lobster, brown crab and scallop catches all declined. There are some claims that the shellfish industry has been pretty much wiped out by the octopus bloom in some parts of the UK. In fact, the implications for fisheries have been so big that we're dedicating a second episode to this. So tune in the week after next to find out more as we ask the question of, should we be eating octopus?
Yeah, so of course, fishers were the first people to report this octopus bloom, but divers very shortly began to add to these reports. So while you do see octopus when you dive off the coast of the UK, sightings are usually a really rare treat. But at one point during this bloom, 12 octopus were seen at once in Plymouth Sound.
When we're talking about an octopocalypse and lobster pots stuffed full with octopus, I have to say 12 octopus in Plymouth Sound isn't wowing me.
Yeah, that's fair, but it probably would wow you if you were a diver and you kind of realize how rare and exciting it actually is to see an octopus when diving. So I have heard stories of people who have been diving around the UK coastline for 30 years and have never seen an octopus.
Okay, that gives me more perspective. Thank you.
Yeah. So overall sightings around the south coast of the UK actually increased by 1,500%. It's a really, really exciting thing. And I personally cannot imagine seeing 12 octopus on one dive. I would lose my mind with excitement if I did. Octopus are a diver's favorite. So they're really highly intelligent animals and they're often quite interactive with divers. And there's also a pretty good reason that they're not often seen is that they're incredible at hiding. So not only, like I say, can they squish into little teeny tiny holes, but they also have this incredible ability to change color and camouflage completely and with their surroundings. So although it's very rare for divers to see an octopus, it's very likely that when you're diving, an octopus can probably see you. So we wanted to dig in a little bit as to why this might be happening. So Dr. Emma Sheehan, Professor of Marine Ecology from the University of Plymouth, has been quoted as saying that perhaps conditions have improved, habitat quality has improved due to better environmental management, or there could be higher survival rates due to milder winters, or perhaps even reduced fishing pressure was playing a role.
That's an interesting positive spin on things. We've got increased habitat quality, reduced fishing pressure. We wanted to know more about this. So the first guest we spoke to is Dr. Bryce Stewart. He is a senior research fellow at the Marine Biological Association in Plymouth, England. In 2026, Bryce, along with some colleagues, including Emma, released a paper investigating the octopus bloom and its potential causes. This is what he had to say.
What we think caused the bloom is a combination of warmer than average seas, which is important for this species of octopus because it is naturally a warmer water species. So its natural or more common natural range is in the Mediterranean, also on the Atlantic coasts of Spain and Portugal, then down across North Africa, all warmer places normally than the UK. So yeah, warmer waters than average have sort of created the right conditions for them to thrive. But they had to get here somewhere. And what we think happened is there was breeding of octopus in probably the Channel Islands or northern France, for example, Brittany, where they've also seen blooms in the last sort of 5 or 6 years. And then when these octopus eggs hatch, their larvae can spend anything up to 4 or 5 months basically in the water column, so being carried by ocean currents. We modeled what would happen, for example, if an octopus egg hatched in March last year off Guernsey. And the amazing thing when we did that was they ended up on the southwest coast of England, exactly where they were seen, like exactly where the fishermen were catching them. But then since then, particularly last year, they've been breeding a lot in UK waters. So the sort of ongoing nature of the bloom into this year is probably being largely fed by local breeding of octopus, off the south coast of Devon and Cornwall, that's since then spread even further around to the north coast and up to Wales as well.
It's not the first time this has happened. There were previous octopus blooms in 1899, 1932 and 1950. But these all lasted around a year and then were probably ended by cold winters. The adults can't survive or reproduce in such cold conditions, and so they die off. Normally, our waters are too cold for octopus to thrive in any great numbers, but the UK hasn't had a below average temperature since 2010, so we're not experiencing these cold temperatures that might cause the octopus to die off.
Yeah, so this is the largest octopus bloom that the UK has had in 75 years, and all previous events have coincided with unusually warm waters, just like we've seen this time. So Bryce described just how warm it's actually been.
We've had warmer than average temperatures, for a number of years, for decades, really. It's been building and building on average, but particularly in the last 2 years, somewhere in the English Channel, there's been a marine heat wave almost constantly. And most recently, just in the past month here, we've had an exceptionally strong or extreme marine heat wave. So water temperatures have been sort of up to 4 or 5 degrees above normal Celsius. If you consider the fact that most marine organisms regulate their body temperature based on the water that's around them, that affects their core temperatures. That's like us getting a fever of like 4 or 5 degrees, basically.
I was pretty shocked to hear quite how much higher sea temperatures are here at the moment, even though just from physically being in the sea, I've noticed it. It's really striking. Another thing that's different about this octopus bloom is the fact that octopus now seem to be breeding here.
So one reason they're so prone to blooms like this is their ecology. They have this real live fast, die young kind of attitude. So adult females will produce thousands of eggs, and they're actually really good mums. They take really good care of them. And then these tiny little glass-like octopus hatch. They're almost a bit more like squid, and they float to the surface where they exist in the plankton for a while, and they learn to swim and hunt, and they grow bigger. And after a few weeks, they drop to the bottom and live out their adult lives. But they only live anywhere from about 6 months to 2 years. So it doesn't take years and years to see a population of octopus grow. It really can happen in months when conditions are good enough for them to kind of jump in and take advantage.
And the fact that they are now breeding in our waters does point towards climate change. We already know that climate change is fundamentally reshaping marine ecosystems. Species are shifting out of their normal range. Many of them are spreading north, especially in the marine environment, and this could be an expansion of their range. So populations will extend further north without any of their range being lost. Or in other cases, it could be a sign that conditions are no longer suitable for them in the southern parts of their range. So their range might be expanding north, but it's contracting elsewhere. I think it's safe to say that a lot more change is in store for our ocean ecosystems.
Yeah, for sure. As we know, change is a real constant in nature, but it's not always a good thing. When ecosystems change this dramatically, especially when we know the ocean is under such intense pressure, it can often be a symptom of something far worse happening below the surface.
Yeah, and while I liked Emma's optimistic suggestion that octopus could be rising due to improved habitat management or reduced fishing pressure, I'm also conscious that animals that exhibit this live fast, die young strategy with lots of offspring don't generally boom due to improved ecological conditions. In fact, quite often it tends to be the opposite. Ecological degradation often favours species that live in this way because when conditions change, they can easily outcompete the animals that have a slower way of life.
Yeah, well, this was exactly my thinking and my suspicion. So I did some digging, and my search led me to an article that suggested we could be looking at something quite a lot more concerning. So the article is very ominously called "The Cephalopods Are Coming," and was written by our next guest, Professor Peter Ward, a professor of biology and earth and space sciences, which is probably my dream job title at the University.
You can do it.
Yeah, that's
Something
my
to aim
goal.
for.
One day, I've just got to get that space part in there. At the University of Washington. So for those who don't know, cephalopods are the group of animals that octopus belong to, which also includes squid and cuttlefish, and the less commonly known nautilus, which we're going to meet a little bit later on in the episode. Peter is a paleontologist who has studied cephalopods and mass extinctions for more than 5 decades. So I want to start by just reading you a quote from his article. There were probably at least 100 species of cephalopods living in the shallow, warm waters in the 2 to 5 million years after the Triassic mass extinction. It was a marine biology unlike anything humans have ever witnessed. Today, the Lyme Regis fossils tell us a clear story. The survivors of the Triassic mass extinction were the seed stock of a great cephalopod flourishing. I see signs of that story today, similar in ways both familiar and horrifying. It is as if our world is like the one at the end of the Triassic. Signs point towards a mass extinction, the 6th in the geological time of animals, that is either completed or heading towards finality in our ocean communities.
That's really quite striking because in many ways, the extinctions around us feel very remote. You hear in the news that a frog in a jungle somewhere you'll never go is extinct. But when you start to compare this to previous events and how dramatic they were, that is a reminder of just how scary this is.
Yeah, I've got to be honest, I struggle to read that quote a little bit. It's so hard hitting. And I think we hear a lot of the science about how much has gone and how much we've lost. But when we start seeing these really clear ecological signals that have been seen before, that we can see have happened before in history, that really could point to this being actually a reality of our oceans, that hits a lot harder, I think.
Yeah, it's not just, it's sad, we've lost something that's important to us. It's the ecological change that comes with us. It's the whole way the natural world is being reshaped.
Yeah, and as much as I love octopus and cephalopods, I think they're incredible animals, what they're signalling could actually be something quite scary. So to find out more about this, I had to talk to Peter. So to start with, Peter takes us on a journey back in time about 200 million years to the time between the Triassic and the Jurassic periods.
Well, there were supposedly 5 gigantic mass extinctions during the time of animals, what we call the Phanerozoic period, the last 540 million years. And one of these at the end of the Triassic was, as were most of the others, caused by enormous, rapid global heating. Too much carbon dioxide entered the atmosphere. The oceans became extremely warm. So the problem is if you heat the oceans, it gets warmer and they become less and less oxygenated. And so many animals really need a lot of oxygen to survive. So at the end of the Triassic, big mass extinction, it was caused by flood basalt, volcanism, huge quantities of carbon dioxide enter the atmosphere. The whole place warms up and animals began to die because of the lack of oxygen. So we saw that not just at the end of the Triassic, but we've seen it at other periods in Earth history. Go to Lyme Regis and go to Somerset on the other side. And you walk through these Triassic rocks and you can see things disappear. And then you're walking further and all of a sudden fossils reappear in huge numbers. And almost every single one of them is one of these beautiful fossils called ammonite. Why were there so many of these things? Well, it turns out that they were beautifully adapted to low oxygen. They could survive oxygen levels that fish can't. And one of the great stories in the history of life has been this fight to the death for 500 million years between fish and cephalopods. Who's going to be the biggest, baddest, most abundant predator in the oceans? And so fish and cephalopods have competed forever.
So Peter talks here about ammonites. These are an extinct cephalopod. They're related to octopus, but they have spiral shells, and they went extinct about 66 million years ago. They were adapted to living in low oxygen. So is there any analogy here? Are octopus also adapted to low oxygen?
Yeah, octopus are pretty well adapted for low oxygen, actually. They've got 3 hearts, so one of which is big and pumps blood around the body, and then they've got 2 little hearts that pump blood specifically to the gills. And they also have blue blood. So unlike humans, we move oxygen around our body using iron in hemoglobin. Octopus use a copper-based protein called hemocyanin, which is more efficient at transporting oxygen.
I love this. It shows there are so many different ways to solve challenges in nature that the octopus has evolved so differently to us, yet has some of the same intelligent capacities, but hasn't come to the solution in the same way. I personally would quite like 3 hearts. Okay, so warming water is playing more of a role than octopus like warm water. It also holds lower oxygen levels.
Yeah, so Peter also spoke about something called the gill oxygen limitation theory, which says that as oxygen in the ocean declines, fish struggle to extract enough from the water column and they have to move into deeper waters where it's cooler and there's more oxygen. So oxygen is a big limiting factor for fish, but it seems like fish are also better adapted in other ways as well.
If you look at a fish and if you look at a squid, they have the same sort of shape. But the fascinating thing about it is a fish swims towards its prey. A squid has to swim backwards. This is like such a fundamental evolutionary screw up by the squid. Couldn't you have figured out a way to build your body so you could actually see the stuff you're chasing? Come on. So there have been these sort of limitations for a long period of time. And generally the fish have succeeded in being the dominant big predators. But then along come these crises when the oceans heat. And what happens is the fish die out preferentially, leaving the place back to the cephalopods. And I believe we're seeing a brand new chapter where, once again, the fish have been removed because we eat them. I mean, we are just as efficient as a mass extinction. We are a mass extinction. We are the meteor, as has been said too many times.
Interesting. So at the end there, Peter mentions fishing. Am I right in thinking he's suggesting that fishing has played a big role in removing enough fish so that cephalopods are now able to fill that niche?
Yeah, essentially, as both predators and the main competition of octopus, Peter thinks that decimated fish populations are actually playing a really big role.
in almost every case where we humans have really decided we like fish and chips or we like salmon where I live, it's never sustainable. There is nothing really sustainable in any sort of fishery. We fish it down to removal. So I guess the best example of all is the Great Banks of Eastern Canada. For centuries, humans have been fishing this extremely productive place off the east coast of Canada for codfish. And it was thought that the cod were just inexhaustible. And we took so many cod off this that they could no longer reproduce in numbers that were sustainable, and the population crashed. And I can guarantee if you go to the Grand Banks or if you go to any of these places where the fishes have been preferentially removed, you're going to find a whole bunch of cephalopods. The fact is that the populations of almost every population of cephalopods has been increasing. And there's a simple reason for this. Fish are their major predators when they're small, and their major competitors when they're big. And so with the removal of fish, you have cephalopods that are no longer preyed upon, and they no longer have such competition for food. So their numbers are exploding.
Okay, interesting to hear him say that lots of cephalopod populations have been increasing, which matches with what I'd read in a study called Global Proliferation of Cephalopods that supports this broader claim. The study found that over 6 decades from 1953 to 2013, there were consistent population increases across a diverse range of cephalopod taxa. Their suggestion was that the cause of this is complex because, of course, humans have altered the ecosystems in lots of ways. But it is interesting that he mentions overfishing, and I can see how it could be beneficial for octopus if both the fish competitors were removed and also their fish predators.
Yeah, it's double trouble. It takes away both what's eating them, but also what's eating their food. So it completely releases them to fill this niche. So I want to talk a little bit about a different type of cephalopod. So Peter actually works mostly with the lesser known species of cephalopod, Nautilus. So weirdly, cephalopods are actually mollusks, and that's the same group as slugs, snails, mussels, oysters, that type of thing. While a lot of mollusks still have shells, a lot have also lost them. And cephalopods have sort of done something in between. So octopus have no hard shell left at all. The only hard part on an octopus's body is their little parrot-like beak. Cuttlefish and squid have a kind of internal skeleton. So squid have a sort of semi-flexible spine, and cuttlefish have those bones that you famously find washed up on beaches. But one type of cephalopod has completely retained its shell, and that's the nautilus.
Nautilus are so beautiful, and if any listeners don't know what they look like, I would recommend that you Google them because it's very hard to describe. They're in a spiral shell, but the shell sort of looks upside down compared to a snail. The spiral goes above the nautilus's head with just its tentacles and eyes poking out.
Sadly, I don't have a Nautilus t-shirt to wear for this episode, but I do have this really beautiful painting of a Nautilus that I bought from a second-hand shop on the island that I live on. And
oh, wow.
It's beautiful, isn't it? And I totally forgot I had it, but I should have propped it up more, obviously, in the background of this episode.
Well, you can prop it up now.
Yeah, I will. I don't know where. It's kind of in the background, but you can't see it because my big head is in the way. So anyway, they're super sci-fi. So they just hover along in the water column. They move really, really slowly, and they're actually scavengers. So in Peter's article, he talks about when a nautilus detects a food smell, they move towards it, but they float so slowly that normally by the time they get there, the food has gone, which really breaks my heart to think about. But anyway, Peter has been monitoring nautilus populations since around 1975. And I asked him what kind of changes he'd seen in that time that concern him the most about how our oceans are changing. And this is what he said.
Well, the biggest change to me has been the reduction in sharks. I mean, I have worked in most of the island nations that have nautilus. I mean, I go where they are. The major places of what we call the Coral Triangle, a beautiful island, New Caledonia, the entire Great Barrier Reef, Papua New Guinea. Every one of these places is where we have spent multiple expeditions trying to understand this animal. For year after year after year, we went out with big deep water cameras and we're trying to get an honest population count. Nobody knew how many nautilus there were down there. But we have 1,000 hours of videos from 200 meters, 300 meters. You put down a bait stick, you put these cameras down. you get 10 hours of video each time. That's dreadfully boring at first, but then you see all the animals that want to eat meat, which is almost everything at 200 meters. We start using stopwatches. We can get an estimate of abundance by how fast does it take for a specific creature to get there. And so this way we are able to calculate how many nautilus there are and were. And actually, it's pretty small. There are 2 or 3 or 5 per square kilometer in a lot of places. But what we also saw was a reduction of sharks. I mean, when I first started my work in 1975 in New Caledonia, we were the first people really to go outside the reef in the dark, swim down and watch nautilus swim up, because it's one of the places you can do it. But there's some really big fish down there. Tiger sharks are really scary animals, and they are routinely patrolling out there, or at least they were, and diving in the 70s and 80s. I've the last 5 trips, I've not seen a single shark, not even the little reef sharks.
That is really sad to hear the decline, but I also can't stop thinking about how cool it would be to do a deep sea video of nautilus populations.
I'd never considered that you could dive with nautilus before, and it's immediately added to my bucket list. The way he talks about it, to see a nautilus just appear from the dark depths of the ocean would be incredible.
Yeah, absolutely stunning and amazing to think of all these things that are going on in the depths of the ocean. I'm not sure I would want to come face to face with a tiger shark on a dark reef, but it was really sad to hear how few sharks there are. His story once again drives that point home. You said he's been diving since about 1975. I imagine he has really noticed the changes in that time. And interestingly, I also read a study from 2021 that reported a 71% decline in the global abundance of oceanic sharks and rays since 1970. So that's almost exactly the timeline that Peter's talking about.
Yeah, and it isn't just sharks either. So in 2024, a global assessment of over 230 different fisheries found that stock assessments are frequently overstated. So finding that 85% more fisheries than originally predicted had crashed to below 10% of their original abundance. So it really can't be denied that our impacts on the fish populations have been devastating. And it seems really likely that this has effectively opened up an ecological niche in the same way that mass extinctions have previously done.
And we know from looking back at the fossil record that mass extinctions can be identified through changes in diversity and abundance of species. For example, huge drops in diversity of species, loss of entire groups of organisms, and sometimes huge evolutionary bursts of surviving species, such as cephalopods, for example. Can we tell based on that what the next stage might be for us now?
Yeah, so the next big clue on this mystery adventure is something that we are pretty unlikely to see happen in our lifetime. So Peter says what happens from here is the cephalopods are likely to find increasingly interesting ways to fill this empty niche through adapting and evolving and forming new species.
So one of the fun things, going back to the mass extinctions, it's as if we've had this awful catastrophe, which is what happened, and then you started the new day. So, okay, the Triassic is over. Let's start day 1 of the Jurassic. Now, the analogy we use is like a horse race. But the horse race now, what we're racing toward isn't how long can I live, how many of me can there be, but for entire groups, it is how many new species can I produce and how quickly. Once you've reset everything, who can produce the most new species the fastest? So you've cleaned out almost everything out of these ecosystems, and yet there's many different ways to live. How quickly can I evolve into the many different kinds of things that eat things? After every mass extinction, the cephalopods are champion evolvers. They can produce more kinds of new species with different morphology faster than the fish do. But then over 10 million years or so, the fish catch up and they're more efficient in many of the things, like this whole idea of swimming backwards towards food, swimming toward food. They're just quicker and better in many ways. And the fish gradually overtake the cephalopods, and the cephalopods become more minor elements. That's the way this works over and over. Well, we are now in day 1 of the new Jurassic, if you will, or at least we're getting there. So for the next 1,000 years, I think we are going to see this evolution of new stuff taking place because we're going to keep eating those fish.
So it looks like in our lifetime, you or I are not going to be able to find out whether or not this is a symptom of a mass extinction.
No, I think in the shorter term, it's likely that other things might start to become more obvious. For example, if we continue to see rising cephalopod numbers while fish stocks crash and waters continue to warm, that's going to be fairly obvious. At the moment, every year we're seeing the ocean change more and more dramatically. So it's likely that at some point this will become undeniable.
But the story is not yet over. As we've seen from so many recovery stories, such as the recent bluefin tuna in the UK waters, we know that nature has incredible resilience and it can rebound if we change our practices and allow it the opportunity to do that.
Yeah, absolutely. As always, the solution here is kind of likely to be simple, but not easy. So in some ways, the damage is already done, but the sooner we can make dramatic changes to our extraction of fish stocks and production of fossil fuels, the easier it will be for nature to rebound. But obviously, this just takes huge political and legislative drive and a lot of people to kind of back up the movement.
And hopefully we can be some of those people. Okay, based on what you've heard, do you think the Octopocalypse is a sign of a mass extinction?
Honestly, to me, yeah, this seems fairly clear. We've got the data on what we've done to the oceans. We know we've decimated populations that would normally predate on and outcompete octopus. We know ecologically that when a niche opens up, another species will jump in and fill it. To me, all the puzzle pieces are there. But do I think it's a reason to despair? I would say no. I think octopus are incredible creatures. We should enjoy seeing more of them while we're here, but also take it as a sign that we need to dramatically change our behavior.
Yeah, I completely agree that this is a really powerful argument for us changing our behavior. I was already convinced that we're living through a time of extinction, and also through what I've heard from Peter and Bryce, yeah, I am convinced that the expansion of cephalopods are a worrying sign of ecological degradation. Interesting to remember that after an extinction, there's always been irradiation. And if what you care about is biodiversity, then bring on extinction. You'll get more diversity in the end. So I don't actually have any worries about nature's long-term capacity to adapt. And actually, these spread of octopus, for example, is helping prove that, I think. But I am very worried about what this means for us in the short term. So yeah, completely agree with you about your point that we need to change our behavior, including in terms of tackling climate change. So that brings us to the end of the episode. I think there are some very striking facts in there, but there's lots more to explore. And there are some positives to take away from this, including, for some people, the chance for creating an octopus fishery. That's why the week after next, we'll hear from Bryce, and I'm very pleased to say that we have a special guest, Professor Peter Godfrey-Smith, who's going to be talking about sentience and what it feels like to be an octopus. So tune in 2 weeks' time to discuss the question of, should we be eating wild-caught octopus? In the meantime, we would be really grateful if you could click like and subscribe on whichever platform you're listening to. Thank you very much for listening. See you next time.
See you next time.